Hello everyone. So today, now I'll be discussing about the another topic that is, let's say, this softmax activation layer. So the softmax activation layer is the topic. In this topic, we are actually seeing that how we are categorizing when there are multiple classifications are taken consideration. So there is, for example, we are taking we have to recognize whether that image is cats or dogs or baby chicks or some other animal for that matter. So I can say that cat is in one, dogs is in, can say, two, baby chicks is in three, and the other animal is represented as zero. The same is what you can see it in the example below which we have mentioned it. Okay, now in the softmax layer, the the we are mentioning, we are representing the form of C is equal to the number of classes. So number of classes here is nothing but equal to 4. Now, though this 4 is including the none of the above also, that is nothing but 0 and 1, 2, 3 all. So that is nothing but all the 4 classes are being considered. Okay. So in this, we build a neural network where we use C output units. So there are C output units are there. Okay. So that is what you can see here. C output units means there are, this is 0, 1, 2, 3. So there are that many output units are there. So in this, what we'll see is that what is the probability of, okay, that others is the input, or we'll see the probability of whether the cat is the input, or we'll see that what's the probability of what is the dog being the input, or we'll see the probability of the baby chicks as the input. Okay, so you have the output 4 number of given 4 possibilities, and these which is all these 4 probabilities when added together, that is nothing but the y hat will be nothing but the sum of all the 4 probabilities should be equal to 1. That is nothing but, you can say that the probability in terms of 0 to 1, and the if it is 0.5 is nothing but 50%, 0.6 nothing but 60%, and 1 is nothing but 100%. So out of the 4 possibility probabilities, if it is coming in 0.7, 0.3, it is nothing but 70, 30% or something like that. So to add together, it should be equal to 1. 1 is nothing but 100%. Now, since we are using a softmax layer, okay, or softmax activation layer, so we are actually using, okay, z of 1. Okay, so z of 1 is equal to, you can say, z of 1 is equal to w of l is into a l minus 1 plus b l. Okay, so this is my softmax layer. Okay, I just copy it here. Okay, this is my softmax layer. So how to calculate it? So it is nothing but z of l is nothing but equal to w of l into al minus 1 plus b. So the zl minus 1 is nothing but, zl is nothing but this, the final layer. Okay, so final hidden layer. Okay, final layer of the neural network is calculated by the wl into al minus 1. This is nothing but the activation of the previous layer of previous layer. Okay, and this is nothing but the final layer bias. Final layer bias. And the activation function is calculated by, activation function is calculated by t is equal to e to the power of z of l. So the function that is, see this is z of l is nothing but the final layer. So for this final layer, okay, So for this final layer, that is Z of L, when we are applying the activation function, when we are applying the activation function to this, the final layer, which is it is represented by e to power of ZL, which is nothing but equal to T. Okay, which is nothing but equal to T. Okay. Now, what is Z of L? Now, Z of L, as I said, it is the final layer, which is of 4, 1 dimensional vector. 4, 1 dimensional vector. And the output, okay. So, output which is calculated by, that is output of this Z of L is calculated by A of L. That is the, what is the actual output what we get. Okay, this is represented as, okay, in the 4, 1 vector. Now why 4, 1 vector? Because there are 4 inputs that is coming to the output layer. Okay, so there are 4 inputs that is coming from the output layer. Okay, so that is nothing but equal to e to the power of Z of L divided by summation of j is equal to 1 to 4 Ti. Now Z of L is nothing but, okay, e power Z of L is nothing but the activation function that is applied to the Z of L. Okay, activation function that is applied to Z of L. So Z of L is nothing but the final layer. So how to calculate this? So if you are mathematically, if you want to see this, how it is being calculated, so you have to understand with the example. So you can see that, consider one simple example to understand the Z of L. So Z of L, consider it is uh, 4 into 1 dimensional vector where it is having values 5, 2, -1, 3. So this is a 4 into 1 vector. Now this is nothing but the the values in the output layer. So when we are applying the activation function to it, so this will become, okay, e to the power of 5, e to power of 2, e to power of -1, and e to power of 3. Calculate yourself in the calculator, and you'll get the values as 148.4, okay, 7.4, 0.4, and 20.1. Okay. Now add all this together. This is nothing but summation j is equal to 1 to 4 T of j is nothing but 176.3. Okay. So as you can see here, A of L is nothing but e to the power of jl, summation j is equal to 1 to 4 T of j. Or you can say I is equal to 1 to 4. I is equal to 1 to 4 T of L. So that we can say, okay. So this is nothing but I is equal to 1 T of I. So I rewrite this formula over here, and that is nothing but A of L is nothing but e to the power of Z of L. Okay, summation I is equal to 1 to 4 T of I. Okay, which is nothing but A of L is equal to, okay, this is e power ZL. So this is e power Z to the power of L divided by 176.3. Okay, 176.3. Okay, so this can be written as e power Z. So this can be written as A power L equal to, okay, T by 176.3. Now why it is T? Because this e to power z of I. Okay, so this is nothing but a matrix. Okay, e power z of I, so which is represented as t. So e power z of I, so that is nothing but for all the four values, which is nothing for all the four values. Okay, so that is what we will be mentioning it as t over here. So that is why I have written it as t. So a power L is nothing but equal to T by 176.3. Okay. Now, um, now this T is nothing but one by one we'll have to take. That is T value as e power 5, T value as e power 2, T value is e power minus 1, and T value is e power 3. So all the four values together we have mentioned as T here. Okay. So one by one we'll be taking each T values and we'll be calculating. Okay. Okay. What should be the what is the probability of, okay, the outcome, okay, is cat or dog, or you can say that the chick, baby chick, or the other animal. So for that, again, okay, I'll rewrite the diagram which is mentioned there. So you can say that this is the formula. Now I am revisiting to this. So I'll rewrite this. So you can say that. So this, so what am I finding out here is, I am finding out my A of L is nothing but equal to the T value. T value, and this is nothing but the summation of T value, which is nothing 176.3. Okay. How did I get this? What is this T? T is nothing but my e power 5, e power 2, e power minus 1, and e power 3. Okay. And this is nothing but equal to 148.4, 7.4, 0.4, and 20.1. Okay, this is what the value, each value. So e power 5 is nothing but 148.4, e power 2 is nothing but 7.4, e power minus 1 is nothing but 0.4, and e power 3 is nothing but 20.1. Okay, so the total value of this is nothing but 176.3, and this is the formula which we have got it from. A power L is nothing but equal to e to the power of z of L, okay, divided by summation, okay, I is equal to 1 to 4 Ti. Okay, so from there we have got this. Okay, and this is nothing but the total T value, that is the total T value is T of I, and this T value is nothing but e power 5, e power 2, e power minus 1, and e power 3. So now what we are going to do is, for each one of them we'll be applying this formula. So for first output layer, I am calculating the e power 5 divided by 176.3, which is nothing but we get it as 0.842. Okay. Second, that is e power 2 divided by 176.3, which is nothing but equal to 0.04. And for third one, we'll apply it as e power minus 1 divided by 176.3, which is nothing but equal to 0.002. And for the fourth one, we'll apply it as e power 3 divided by 176.3, which is nothing but 0.114, which is okay. So this 0.842 is nothing but 84.2%. So for first node, it is 84.2%. Then 0.042 is nothing but the 4.2%. So second one is the 4.2%. So for the third one, it is 0.002, which is nothing but the 2%. and the fourth one is 0.114, which is nothing but 11.4%. So you can say that the possibility of for this particular, that is your A of L, is nothing but the other animal. So 84.2 is the highest possibility, being the none of the above. So your y hat is nothing but your this particular part, and the other animal is what the highest probability is, what you can see over here. Okay, so now this is an example of software max, where you can see that in this case there are two inputs which we are taking, that is x1 and x2. So when x1 and x2 is applied as an input, okay, so applied as an input to the single layer softmax layer. So this is of three nodes. So you can see that there are three possible outputs. So when we are giving three nodes, okay, and then what we get is nothing but the y hat. So this is nothing but the softmax layer, and there is no any hidden layer. So you can say that z of 1 is equal to w of 1 x plus b of 1. Okay, that is nothing but the output layer, that is this z of 1 is nothing but w of 1 x is nothing but the of the activation of the previous layer. Okay, this activation of previous plus b of 1 is nothing but, no, there is since there is only single layer here, so that is why I am using w1 of x, okay, plus b. Now a of 1 is nothing but the output to this z of 1 is nothing but equal to y hat, okay, which is nothing but g of z of. Now what is this g of z of 1 is nothing but this g is nothing but the softmax activation function given to the final layer, okay, given to the final layer. So this is nothing but the notation which we are giving for the final layer, that is a softmax activation function for the not for the final layer. So the notation is given as g of z of L, or g of z of 1. Since it is only one layer, so it is represented g of z of 1. Now, for the softmax layer, the C is nothing but equal to 3. 3 is nothing but there are three classes that are being considered. Okay. So even in this example where we are giving two inputs, x1, x2, the the possible the classes in this are nothing but three. You can see there are three possible classes. Okay. So we can take the training set, then training the softmax classifier with the three output layers. So these are the three output layers, that is C is equal to 3. Okay, so we can see that which one has the highest possibility. So among this one, or this one and this one, which one is highest possibility, so we have to find out. So when we are training, when we are giving training this with the C is equal to 3, we have to see that the possibility, okay, of which particular, okay, class has the, okay, highest possibility. That is what we are saying. With C is equal to 3, we are getting this. Another example with C is equal to 3 is this one. So this another C is equal to, so this also C is equal to 3. We are seeing that which one has the highest possibility, that is what we are seeing. Then another example with C is equal to 3, where you can see that the distribution, which is, see, we can see that in the first two example, the linear function being used is different, whereas in this example, linear function use is different. Okay, where we are separating the three different classes. So we are separating three different classes in this way. Here you can see that separation is done. So for all these different uh, categories or classes, we are using the different linear functions. So linear function used for this and for this are different. So that is, hence we can see that the separation that is between those different classes, okay, can be seen here. Now this is about, so this all these three we had seen it as c is equal to 3, c is equal to c. Now this is nothing but c is equal to, we can say it as 4. Okay, so there are 4 classes. Okay, so 4 classifications. Now again we are training with respect to c is equal to 5. This is nothing but c is equal to 6. So this c is equal to 3, c is equal to 3, c is equal to 3, c is equal to 4. Yes, c is equal. So there are how many? 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5, 6. Okay, so totally there are 6. Okay, so this is about softmax activation function. Any doubt is there, we can discuss later. Thank you.